Hello, very good morning. Today, our topic is networking troubleshoot components. In the topic network addressing and management, in the last class, we have seen establishment of LAN. So now our class is network troubleshoot components. So after establishing the LAN or establishing the network, there are chance of occurring problems in networking. There are number of problems are occurring, number of problems are arising due to misconfiguration or some other things, or damage of cables, or not work due to not working of networking devices. There are certain problems are occurring in the network. So we have to troubleshoot those problems, and we have to overcome those problems with certain troubleshooting components and also certain troubleshooting tools. So first thing, what is troubleshooting a network? So before going to see, the components are tools which are used for network troubleshooting. Before that, we must see what is meant by network troubleshooting. So the term troubleshooting refers to the process of identifying problems with a network through a rigorous and repeatable process, and then solving those problems using testable methods. So it is a troubleshooting is process of identifying the problems and also solving those problems. Troubleshooting is more effective than trying things at random until the network functions, because it allows to target individual network components, testing each function, and encourages to document the process. So network troubleshooting is useful for almost anyone, from a computer enthusiast to an aspiring network engineer. So here troubleshooting is refers troubleshooting refers the process of identifying problems and also solving those problems. So troubleshooting is more effective than trying things at random. Some people try the things randomly to set right the problems, but a systematic troubleshooting approach is required. So generally, what are the network problems? By some estimates, 75% of the network outages and performance issues are the result of misconfiguration, and more often than not, these misconfigurations are not discovered until they are in production. So generally, some network issues are misconfigured, and those are not recognized until problem exists. So this is stressful for network administrators and architect, not knowing the impact of a configuration change in a firewall rules or routing rules makes network monitoring reactive rather than proactive, introduces a risk and leads to long troubleshooting times. So most of the problems in the network are due to misconfigurations. Until unless they are discovered, they produce the misconfiguration continuously and cause the network problems. So we have to find out these type of problems in troubleshooting. So generally there are these are the basic network problems: cable problem, connectivity problem and configuration issue. So generally the cable which is used to connect two devices can get faulty, shortened, or can be physically damaged. So these three possibilities occur in case of cable problem. So we have to see whether the cable is faulty, or wherever we have to check if the cable is shortened in anywhere, or if the cable is physically damaged at all. Next, network problems, connectivity problem. The port or interface on which the device is connected or configured can be physically down or faulty, due to which the source host will not be able to communicate with the destination host. So this is a connectivity issue, because if the source is unable to communicate with the destination host, we can say it is a connectivity problem. And this connectivity problem may be due to misconfiguration, or physically down, or faulty, or any physical damage may be done. We have to check it out. The next network problem is configuration issue. Due to a wrong configuration, looping the IP, routing problem, and other configuration issues, network fault may arise, and the services will get affected. So this is the most important factor in networking problems, because sometimes there will be no cable problem and there will be no connectivity issue, but still there is a malfunction in networking. So that may be because of configuration issue. So we have to check in troubleshooting methods whether it is a cable problem, or connectivity problem, or configuration issue. And another networking problem is software issue. Owing to, owing to software capabilities issues and version mismatch, the transmission of IP data packets between the source and destination is interrupted. So generally, software version mismatches occur, and due to the software incompatibility issues, so there will be software problems. Next network problem is traffic overload. This is generally occurring every day due to increase in traffic. If the link is overutilized, then the capacity or traffic on a device is more than the carrying capacity of it, and due to overload condition, the device will start behaving abnormally. So we must not send the data in the overload mode. So we cannot send the data than over capacity, which actually the link can bear. Next, network IP issue, another networking problem. Due to improper configuration of IP address and subnet mask and routing IP to the next hop, the source will not be able to reach the destination IP through the network. So this is IP addressing issue. So these are the networking problems we can categorize: cable problem, connectivity problem, configuration issue, software issue, traffic overload, and network IP issue. So these are the general basic networking problems occur daily. So we have to overcome this by troubleshooting. So if we see the network troubleshooting flow chart, start, we have to define the problem, gather the facts, and next step is consider the possibilities, and next create an action plan, implement action plan, observe results, utilize process. Here, after observing the results, do problem symptoms stop? Yes, if it is yes, Then problem resolved, document the facts, and the finished work is finished. If the problem symptoms stop, if we say no, then again utilize the process, again we go back. If required, gather facts again, consider the possibilities again, or create the action plan, implement the action plan, and so on. So this is the network troubleshooting flowchart. Here also, these are the best practices, network troubleshooting best practices, we can say. So here we are collecting the information, customize the logins, check the access and security, and then flow on escalation framework and use monitoring tools. So this is best practices in network troubleshooting. So basic network troubleshooting steps. What are the network troubleshooting steps? While troubleshooting, we must follow some steps. The network troubleshooting is a repeatable process, which means that we can break it down into clear steps that anyone can follow. So I have to break down the complete network troubleshooting. We have to break down into steps. So those steps can be followed by anyone. So first one, identifying the problem. This is the basic thing in network troubleshooting. We have to identify the problem. The first step in troubleshooting a network is to identify the problem. As a part of this step, we should do the following. What are these? Gather information about the current state of the network using the network troubleshooting tools that are available. Duplicate the problem on a test piece of hardware or software if possible. This can help to confirm where the problem lies. Question users on the network to learn about the errors or difficulties they have encountered. So identifying the problem, now identify the symptoms of the network outage in the first step. Example, do they include complete loss of network connection? You have a question. Slow behavior on the network. Is there a network-wide problem or the issues only being experienced by one user? If the problem is experienced by one user, the troubleshooting will be different. And the problem is experienced by all the persons. It's a wide problem. If it is a wide problem, the troubleshooting will be different. Determine if anything has changed in the network before the issues appeared. By questioning, is there a new piece of hardware that's in use? Has the network taken a new users? Has there been a software update or change somewhere in the network? So anything has changed, we have to check and define individual problems clearly. Sometimes a network can have multiple problems. This is the time to identify each individual issue so that the solutions to one are not backed down by other unsolved problems. So while troubleshooting, our solution must be wide range. So next step is to develop a theory. Once finished gathering all the information about the network issue or issues, it's time to develop a working theory. While producing the theory about the causes of the network issue, remain on the lookout for more serious issues. Sometimes a network outage occurs because someone tripped on a wire or some other simple problem. However, at other times, the problems might be related to more complicated causes like a breach in network security. So after gathering the information, we have to think if any serious issues may occur in the future also. So we have to note down all this. So test the theory. Using the tools, it's time to test the theory. If the theory is that the network router is defective, try replacing it with another router to see if that fixes the issue. At this stage, it's important to remember that proving own theories wrong does not mean that we have failed. Instead, it means that it's time to return to step two, develop a new theory again, and then find a way to test that one. Sometimes the first theory may be right, but it's also common to go through several theories before arriving at the true cause of the network issues. So we have to test the theory in different perspectives, then only we can achieve the goal. If you test in one way or depend on one theory, then we may not be able to solve the network problem, entire network problem. So we have to think in different perspectives to troubleshooting our network issues. The plan of action we have to prepare. Once confirmed the theory about the causes of the network issues, we are in a position to solve the problem. Come up with a plan of action to address the problem. Sometimes the plan will include just one step. Example, restart the router. In other cases, the plan will be more complex and take longer, such as when need to order a new part or roll a piece of software back to a previous version on multiple users' computers. So we have to prepare a plan, action plan. So based on that action plan, we have to work out the basic networking problems. So now implement the solution. Now that we have a plan for fixing the network, it's time to implement it. There are some solutions that may be able to do by ourselves, while others may require cooperation from other network administrators or users. Verify system functionality. Once we have implemented a solution, be sure to test the network. Make sure that the issue in question has been resolved, but also be on the lookout for other issues that may have arisen from the changes that made to the network. This is most important thing that we have to question, we have to make questions, and also we have to see and look out other issues, because that may arise after changes what we have made to the network. Due to the original problem, we are changing uh, some changes we are making to the network. So if the changes are after making the changes, again we have to see if any problems arise or not. If the changes are working good, changes are working properly, then there will be no issue. If the changes made to the network, if anything arises due to these changes, so again we have to check the network. As part of verification process, make sure to consult both the network tools as well as individual user accounts of their experience on the network. Now document the issue. Make sure to document each stage of troubleshooting the problem, including the symptoms that appeared on the network, the theory developed, the strategy for testing the theory, and the solution that we came up with to solve the issue. This is most important. So what the problem we encountered, and what the theory we have developed, what the strategy we have applied for testing, and what the solution we came up. So all things we have to document. Even if you don't reference this documentation, it may be helpful to another network engineer in the company in the future and could help to shorten network downtime. So these are the basic network troubleshooting steps we have seen. Now we are going to see the network troubleshooting tools. So we have encountered a problem, we have seen the problem, we gathered the information, we prepared action plan, According to action plan, we have done everything. But what are the requirements for troubleshooting? So we must have troubleshooting components, troubleshooting tools. So in addition to user reports and first-hand experience on the network, there are a number of tools available to use when it comes to diagnosing and treating network issues. These tools may exist in the computer's operating system itself as standalone software applications or as hardware tools that can be used to troubleshoot a network. So there are a number of different troubleshooting components and tools are available. So these exist in the operating system itself and may be available in the form of standalone applications, nothing but third-party software. And also we have hardware tools that can be used to troubleshoot a network. So we will see what are the troubleshooting tools now. So first thing is online command line tools. The most important tools in troubleshooting methods is command line tools. On Windows PCs, the command prompt can be accessed by searching for it in the start menu or by typing CMD into the run window. There we can type commands, the commands which are used to rectify the problems, network problems. And on a Linux system, press Ctrl, Alt and T to open the command line. So here we are going to see the commands which are helpful in Windows as well as in Linux in troubleshooting the network problems. So first and most important thing is the ping. Ping is a TCP/IP utility that transmits a datagram to another host specified in the command. If the network is functioning properly, the receiving host returns the datagram. The ping command operates by sending Internet Control Message Protocol, echo request message to the destination computer and waiting for a response. This is the simple and best thing, nothing but ping, which is used to test the network connectivity between our sender and the receiver. So here at the prompt, at the command prompt, type ping along with the URL or IP address you want to ping and then hit enter. And here we are pinging, that is nothing but www.howtogeek.com and getting normal response. So this is command prompt. Here we are typing ping. So here we are typing URL or also we can type IP address also here. So pinging, this is the reply from, here we are getting the reply from howtogeek.com. So ping command is contacting this howtogeek.com server and it is getting the reply. So pinging howtogeek.map fastlynet, this is the IP address of this URL name is 151.101.206.15 with 32 bytes of data. So it is getting reply. So ping start 6 for this IP address. Packet sent 4, received 4, loss 0. So 0% loss. Approximate round trip times in the milliseconds, it is minimum 14 milliseconds and maximum 22 milliseconds. Its average is 16 milliseconds. So this is the usage of ping command, which can be tested the connectivity between two computers. Nothing but this is our computer and this is another computer where we want to get the information. That response shows URL we are pinging, the IP address associated with the URL and the size of the packets being sent on the first line. The next 4 lines show the replies from each individual here, next 4 lines. This is a response from the URL. This is a response from the URL and these 4 lines tells each individual packet including the time in milliseconds and it took for the response and the time to live of the packet, which is the amount of time that must pass before the packet is discarded. At the bottom, summary that shows how many packets were sent and received as well as the minimum, maximum and average response time. These are the minimum, maximum and average response time. Pinging the router on our local network using its IP address. We can ping the router also, whether our router is working or our router is properly working or not. So, the normal response from it. So, ping 10.0.0.1. This is the address of the router. So, it's pinging with 32 bits of data. So, this is reply from our router. So, here, so the TTL time to live as a ping statistics, 4 received, 4 sent and 4 received, and minimum 1 millisecond, maximum 2 milliseconds, average is 1 millisecond. So this is about ping. And another command line tools is a tracer or tracer route. This is also TCP/IP utility that determines the route data takes to get to a particular destination. This tool can help to determine where we are losing packets in the network, helping to identify the problems. The tracer and the tracer route. The Windows tracer tool determines the route to a destination by sending IC and the packets to the destination. In these packets, tracer uses verifying IP time to live TTL values. The TTL is effectively a hop counter where a hop is a location that the packet stops at to reach the destination. The tool may take some time to complete, particularly if there is a problem, as the tool waits for responses which may not come. Now, next tracer root is the root tracing tool used in Unix-like operating system, including Mac OS X. On Mac OS X, we can access tracer root through the network utility. So this is about tracer root, preset and tracer root. It's a tool in troubleshooting the network. Next one, command line NS lookup. It is a DNS utility that displays the IP address of host name or vice versa. This tool is useful for identifying the problems involving DNS name resolution. To use the NS lookup tool, we will need to provide the following. You have to provide the host, the domain you want to look up, and query type. The type of the record we are requesting, we can return just one type of record related to the host name, or we can return all the records. Note that some servers require to ask for a specific type of record, otherwise they won't return it. Once provide the required information, click go. So this is the nslookup command. It is a query, the DNS for resource records. We have to give the domain request and query type and server and also query class and port address and timeout. So after entering all this, we have to press this one. So the information related to the DNS will be displayed. So next command in command line tools ipconfig. This is another most important command, IP internet protocol configuration. IP stands for ipconfig stands for internet protocol configuration. A Windows TCP/IP utility that verifies network settings and connections. It can tell a host IP address, subnet mask, and default gateway alongside other important network information. So this is a TCP/IP utility, verifies network settings and connections. And it tells the host IP address, subnet mask, and default gateway. So here ipconfig briefly show the configured network. These are the different options available in ipconfig command. Briefly show the config. This ipconfig simply show the configured network adapters information such as IP address, subnet mask, and gateway. ipconfig/all. This command shows detailed information of network adapter that includes IP address, subnet mask, gateway, DNS, DSCP, MAC address, etc. And ipconfig/release command. This release the IP address of network adapter, mainly used for network adapter that relies on the DSCP server to obtain IP address. ipconfig/renew. It renew the IP address of network adapter, mainly used for network adapter that relies on the DSCP server to obtain IP address. ipconfig display DNS, display the contents of DNS resolve or cache. ipconfig slash flush DNS, clear the DNS resolve or cache. ipconfig slash question mark, display detailed command usage information. So this is about ipconfig options. So here we have to, in the command prompt, we have to press, this is command prompt, here we are giving ipconfig and enter. So Windows IP configuration, it is displaying Ethernet adapter local area connection specific, DNS specific. This IP address, it is displaying, subnet mask also displaying, and default gateway, it is displaying. So every details will be displayed, it is brief information. So if we give the option like this, slash r slash release slash renew and slash display DNS and slash flush DNS and slash question mark and display the information according to the command. So this is about IP config. Next one is a very important thing, if config, and this is related to Linux or Unix TCP IP utility. So if config is interface configuration. It's a Linux or Unix TCP/IP utility that displays the current network interface configuration and enables to assign an IP address to a network interface. Like ipconfig on Windows, this command will tell the vital information about the network and its status. Common Linux users uses ifconfig command to assign IP address and uh, net mask to an interface or to disable or enable a given interface. So ipconfig also show the network devices and configuration and all network settings. So these are the information displayed in the when we use ipconfig in the Linux prompt. So it displays the IP tables and it displays all the information like this. So here is the Ethernet card and LO is loopback address, and this is PPP point-to-point protocol. So everything will be displayed by using ifconfig in the Linux. Next command line tools, it is IP tables. IP tables is a Linux firewall program that protects a network. IP tables is a command line interface used to set up and maintain tables for the net filtered firewall for IPv4 version, including the Linux kernel. The firewall matches packets with the rules defined in these tables and then takes a specified action on the possible match. Tables is the name for set of chains. Chain is a collection of rules. Rule is a condition used to match packet, and target is an action taken when a possible rule matches. Examples of target are accept, drop, queue. Policy is the default action taken in case of no match with the inbuilt chains and can be accept or drop. So the syntax of IP tables command is IP table option A or C or D, chain rule, jump, target. So this is about IP tables. It is a Linux firewall program that protects a network. Next command line command is netstat, nothing but network statistics, a utility that shows the status of each active network connection. This tool is useful for finding out what services are running on a particular system. So here we can use listing all ports, both TCP and UTP, using netstat A option. Here we are using netstat A option or more. So active internet connection servers and established, everything will be displayed, and active Linux domains and servers and established also displayed here with the help of network statistics command. So here it is also displaying local address and foreign address and state. So next command line tools command is TCP dump. TCP dump is a utility that is used to obtain packet information from a query string sent to the network interface. It is available for free on Linux but can be downloaded as a command for Windows. TCP dump is a packet sniffing and packet analyzing tool for a system administrator to troubleshoot connectivity issues in Linux. It is used to capture, filter, and analyze network traffic such as TCP/IP packets going through the system. So TCP dump installing, we have to install. Many operating systems have TCP dump command pre-installed. If this TCP dump is not pre-installed, then we have to install. So I use the following commands for Red Hat based Linux OS: yum install TCP dump, and for Ubuntu and Debian OS we have to use command apt install TCP dump. The next command is ping. A TCP/IP command that provides information about latency and packet loss on a network. It can help to troubleshoot issues related to network packet loss. Similar to the reset command, ping provides users with the ability to locate spots that have network latency and network loss. Ping is an external command that is available for the Microsoft operating systems as ping.exe. So it is ping is available in the form of external command for Windows. Ping that provides useful information about network latency and network loss at intermediate hops between a source address and a destination address. It does things by sending echo requests via ICMP and analyzing the results. So this is about ping command line tool used as a networking troubleshooting tool. So another command line command is nmap. This is network mapper. It is an utility that can scan the entire network for various ports and the services that are running on them. So network mapper is used to monitor remote network connections and get specific information about the network. Nmap is a network discovery and security auditing tool. It is known for its simple and easy to remember flags that provide powerful scanning options. Nmap is widely used by network administrators to scan for open ports and services, discover services along with their versions, guess the operating system running on target machine, get accurate packet routes till the target machine, and monitor hosts. So these are the things can be scanned by the network administrators with the use of network mapper command. So another command line, root, a command that enables manual updating of the routing table. Generally, every router got its own routing information table. So we can update manually by using the root command. Root command is used to troubleshoot starting routing problems in a network. Root is a command line tool that allows user to view and configure their operating system's routing table. So syntax here is root, the options are F, N, Q and C, and V, command family, and net host destination, and prefix length, net mask, address gateway, and arguments. This is the syntax of the root. So root is used to enables manual updating of the routing table. So next one, ARP. This utility that supports the address resolution protocol service of the TCP/IP protocol suite. It lets the network admin view the ARP cache and add or delete cache entries. It can be used to address problems having to do with specific connections between a workstation and a host. This is about ARP, which is address resolution protocol service. So another command line command is dig. It's a Linux or Unix command line tool that will display name server information. It can be used to troubleshoot problems in DNS name resolution. And dig, which stands for Domain Information Grouper, is a flexible tool for interrogating DNS name servers. It performs DNS lookups and displays the answers that are returned from name servers that were queried. Most DNS administrators use dig to troubleshoot DNS problem because of its flexibility, ease of use, and clarity of output. Other lookup tools tend to have less functionality than dig. So dig is a domain information grouper. It is used to troubleshoot the problems in DNS name resolution. So command line tools, there is NS lookup, another command. Some of the most common network issues resolve around issues of the dynamic name system, that is address resolution issues. DNS is used everywhere. Everyone using the internet resolve commonly known domain names, that is example google.com, and to commonly known unknown IP address, that is 74.125.115.147. When the system does not work, most of the functionality that people are used to goes away as there is no way to resolve this information. The NS lookup utility can be used to look the specific IP addresses associated with the domain name. If this utility is unable to resolve this information, there is a DNS issue. So along with the simple lookup, the NS lookup utility is able to query specific DNS servers or determine an issue with the default DNS servers configured and host. So most of the URLs we are browsing with the help of URLs. Every URL is connected, having every URL is having respective IP address. If we want to know the IP address of that URL, we can use NS lookup command to the getting the information IP address from domain name system. So another command line tool is a putty terra term. When connected to a variety of different types of equipment, like a telnet, SSH, or a serial client is required. When this is required, both the putty and terra term programs are able to provide these functionalities. The selection of one over the other is strictly a personal preference. So here we can use putty configuration and everything category. So we can get the information like this. SSH, telnet, and connection type we have to select. And this is Terra term. So TCP/IP we have to give the information about host configuration and also service we are asking, telnet, SSH, or other. So another command line one, subnet and IP calculator. One of the most important is an IP network calculator. These can be used to ensure a correct IP address selection, and with this a correct IP address configuration. Most of the information obtained from the tool becomes simpler to calculate the longer and more experience we have in the field. Two of the more commonly used free IP calculators include wild packets, nothing like bit cricket, and network calculator and SolarWinds advanced subnet calculator. So far we have seen maximum command line tools, nothing but maximum software tools, software commands to resolve the different types of networking problems. So now we are going to see what are the hardware tools available for what are the hardware tools can be used in troubleshooting the network problems. So command line tools and applications are software tools for troubleshooting, but some network problems have hardware causes and the solutions. So here are some hardware tools that can help diagnose and solve network issues. So what are the hardware tools we see now? So first one is a wire crimper. A wire crimper, sometimes called a cable crimper, is a tool that attaches a media connectors to the end of the cables. We can use it to make or modify network cables. So generally this is used for crimping RJ11, that is 6 pin, or RJ45 8 pin crimping tool. Generally in networking we use RJ45 cable. We use a UTP cable, that is nothing but unshielded twisted pair cable, and we can connect RJ45 and also UTP cable to make a network cable. So for this we use the wire crimpers. So cable tester is a cable tester, sometimes called a line tester, is a tool that verifies if a signal is transmitted by a given cable. This can be used to find out whether the cables in the network are functioning properly when diagnosing connectivity issues. If any network problem occurs like a connectivity issue, we can check the physical connectivity between two ends by using the cable tester. In one end, we have to put any of this device, and on the other end, we have to put any of the device. Then we will test if the 8 wires in the tester pair cable are working or not. It will easily tell. It will test the connectivity. Next one, punch down tool. A punch down tool is used in a wiring closet to connect cable wires directly to a patch panel or punch down block. This tool makes it easier to connect wires than it would be do it by hand. Instead of doing in a hand, we can do by using this punch down tool. This is a punch down tool. Next, TDR, time domain reflectometer, is a measuring tool that transmits an electrical pulse on a cable and measures the reflected signal. In a functioning cable, the signal does not reflect and is absorbed in the other end. An optical time domain reflector OTDR is a similar tool but used for measuring fiber optic cables, which are becoming more common in modern networks. So this is a time domain reflector meter. This is one of the TDR. This is another TDR. Next, another hardware tool is light meter. Light meters, also known as optical power meters, are devices used to measure the power in an optical signal. So these are the two different light meters or optical power meters. Next hardware tool is tone generator. A tone generator is a device that sends an electrical signal through one pair of U to B wires. On the other end, a tone locator or tone probe is a device that emits an audible tone when it detects a signal in a pair of wires. These tools are used to verify that signals are passing through the wires in the network. They are often used to confirm phone connectivity also. So this is a tone generator. This is tone generator. So another hardware tool is loop back adapter. A loopback adapter is a virtual or physical tool that can be used for troubleshooting network transmission issues. It can be used by utilizing a special connector that redirects the electrical signal back to the transmitting system. So here these are the loopback adapters. The next one is a multimeter. It's a name itself saying that it's a multimeter. A multimeter, sometimes called a voltameter, is an electronic measuring instrument that takes electrical measurements such as voltage, current, and resistance. There are handheld multimeters for fieldwork as well as benchtop models for in-house troubleshooting. So this is one of the multimeter which checks the voltage level, current level, and resistance level in the circuit. So another hardware tool is spectrum analyzer. A spectrum analyzer is an instrument that displays the variation of a signal strength against the frequency. So it checks the signal strength. So this is the spectrum analyzer which checks the signal strength in the networking. So far these are the hardware tools we have seen which helps in troubleshooting the networks. So now we are going to see troubleshooting applications. In addition to command line tools and also hardware tools, there are also a number of standalone applications that can be used to determine the status of network and to troubleshoot issues. Some of these applications may be included in the system that we are working while others may need to be installed separately. So these are standalone applications which can be used to troubleshoot the networking. So packet sniffer. This packet sniffer program provides a comprehensive view of a given network. This application can be used to analyze traffic on the network, figure out which ports are open and identify network vulnerabilities. Next one, port scanner looks for open ports on the target device and gathers information including whether the port is open or closed, what services are running on a given port, and information about the operating system under the machine. This application can be used to figure out which ports are in use and identify points in a network that could be vulnerable to outside attacks. So another programming application, standard protocol analyzer, integrates diagnostic and reporting capabilities to provide a comprehensive view of an organization's network. We can use analyzers to troubleshoot network problems and detect intrusions into our network. And another tool is another software application, Wi-Fi analyzer. This detects devices and points of interference in a Wi-Fi signal. This tool can help to troubleshoot issues in network connectivity over a wireless network. Next one, software application bandwidth speed tester. This tests the bandwidth and latency of a user's internet connection. This application is typically accessed through a third-party website and can be used to confirm users' reports about slow connections or download speeds. So this is about standalone applications which are used in network troubleshooting. So far we have discussed network troubleshooting components and tools. And first we have seen what is meant by troubleshooting and what are the steps involved in troubleshooting and what are the components and tools available in the troubleshooting. We have seen command line tools and also hardware tools, and also we have seen standard software applications which are helpful in network troubleshooting. Thank you.